We can do the derivative as this function. This is using the power rule and then the chain rule. That is 2x minus 1 to the power of negative 1 over 3 times 2, right?
Yeah.
Now we want to find out this guy's either make this equals to 0 or this guy doesn't exist, okay?
Okay.
So there's no value to make this guy equal 0, but there is value to make this guy not exist, okay? The critical points, including the position where this guy equals to 0 or this guy does not exist. So don't just use that one, but also remember this position is also called the critical values, okay? That makes sense?
Yeah.
Okay. So if we make the denominator equals to 0, we get this guy equals to 0. So x equals to 1/2, right?
Yeah.
Okay. And we also want to put the edge, right? Okay. So those critical values will including x equals to 0, x equals to 1/2, x equals to 1. Does that make sense?
So so to find x, you just find everything that makes it 0 or undefined, I guess.
Right. Yes.
Okay. Wait, so we got, you said x0 would work. How's
this is the edge. You also need to put the edge because remember the candidate's test. We want to also compare with the two limits on the left and on the right. Yeah. Now we can check when x equals to 0, fx is how much, okay? When x equals 0, fx equals to -1 to the power 2 over 3. That guy is 1, right? Because -1 squared is 1, so this is 1. When x equals to 1/2, fx equals to, that is 0, right? So this is 0. When x equals to 1, fx equals to, that is 1. That is 2 minus 1 is 1. So this is still equals to 1, right? Okay. So who is mean? Who is the max? That is my mean value. And that is my max value, okay?
So to find min and max, you plug in all three of them, you just see which one has the biggest value,
right,
and then which one has the smallest value.
Right.
Oh, okay. So it wasn't that bad.
Yeah, we can verify this one, yeah, because this is I think in the previous example, we didn't cover the function which first derivative doesn't exist on those locations. Yeah, and that's why you feel confused. So 2x minus 1, and then here is to the power of 2 over 3. Yeah, you see, that's the reason. And from what? From 0 to 1, right?
Yeah.
Yeah, so we can do the curly brackets, okay? 0. Even if you feel confused, you still can use the graph calculator to help you answer the question. You know? Yes. Look at this.
I'm not as good at using it as you are.
This is a mean value. This is the maximum value, okay?
Okay.
This mean value happens where the first derivative doesn't exist. This max value happens at the location on the edge, okay? Yeah, makes sense now? Okay. So that's how we show this type of questions, the critical point and the mean and max value.
Uh-huh.
Now your second question is, you ask me, does mean value theorem, Rolle's theorem, or both apply to fx on the given intervals?
Yeah.
So your second question.
I know how to identify if Roy's theory works, and I know that's just you plug in the two values and you see if they equal each other, and if they do, then it works. But the part I don't know is I forgot was we had to include stuff talking about it being continuous and differentiable, but I forgot how to do that again.
Oh, okay. So
yeah, I know how to do the formulas for both of those those theorems. I just forgot the differentiable and continuous. I just forgot how to determine that.
So as this one, well, you just say this one. This is equals to x to the power 1 over 3, right?
Yes.
And you don't have any x in the denominator. So this place is always continuous. This is a power function with a positive power exponent. So this is always continuous. Okay.
Okay.
So
and when is it not continuous? Is it not continuous when it's like a fraction and then
right.
the bottom becomes undefined?
Right. Exactly. You don't have anything in your denominator. This one, you don't worry. This is, you just say it. This is continuous.
Okay. What about differentiable?
Then you do it. F prime x. You show them. You see here? This is x to the power of negative 2 over 3, right? Yes.
Mm-hmm.
Is this differentiable? Not really, because 8 and 1, this covers a point of 0. So this is not really differentiable.
Mm.
That makes sense?
Yeah.
Yeah.
So it's not differentiable because what? They're not equal to each other, right?
Because 0 is between negative 8 and 1. And you have a point which your function is not differentiable on this point. You cannot base on this.
Okay. So for differentiable, you do derivative, and then
Right.
you see if there's anything between the two points that they give you. See if there's a point in between that makes it undefined or equal to 0. Either one, right?
Right.
Or is it when it equals undefined, or is it both undefined and equal to 0?
As long as you get one point which the derivative does not exist, you can say nothing doesn't apply.
Okay, so does not exist.
Mm-hmm.
Okay, it can't be equal to 0. That won't work.
Right.
Okay. So to go over just one more time, just so I can remember it. Continuous is you see if there's anything that would make it undefined.
Correct.
Be undefined without doing the derivative. And then differentiable is you do the derivative and you do the same thing as continuous, except you use the derivative form.
Right.
Okay.
Yes. Very good summarize. Okay.
Yeah, because I was doing it yesterday and I was like, I know if I can use the formula, I just don't know if it's continuous or derivative. I was like differentiable. I was like, wait, is it or is it not?
All right.
It was confusing.
Let's continue.
All right.
Let's continue.
Let me look.
Yeah, we have the review. Yeah, you have new worksheets?
No, because I haven't taken math class, but I'm looking at the questions because I took picture of the questions I did to see if oh, okay. Yeah. Okay. So there's one that I would like help with. So it's f of x equals to sine squared.
Would you please send me the screenshot?
Yeah. Okay. Let's see. Find this. All right, let me send this to you. Zoom. Where do I go? Chat. Is that where I send it to you from?
You send to Zoom?
Can you put hi in chat so I know where it is located? Because I'm on my phone. Yeah.
You receive it?
I'm looking. Minimize.
You need to minimize. You need to minimize.
Oh, I see now. Okay.
Okay.
Yeah, it's the first time I'm using my phone. Where is it? Send. This one, I think it's regards to Roy's theorem, I think. Yeah, Roy's theorem. Did you get it?
Really? You see, I don't. You can see my screen. I don't get.
Oh, retry. No, it said something of error. Give me 1 second. I resending. Did you get it now?
Yes. Yes.
Right.
Okay. So your question is, find the value of C guaranteed by Rolle's theorem for the following function over the given interval. Okay. And find the value of C guaranteed. What? They are the same one, right?
Yeah, they just repeated.
Oh, okay. So you are going to find out, because the Rolle's theorem said if this function is continuous and also differentiable on this interval, then you must have a point of C where your f prime C is going to equals to 0, right?
Yeah, and this is continuous and it is differentiable because it doesn't have any undefined stuff.
Right. Okay. So what you do is you find out f prime x. This equals to 2 times sine x. And then times, you need to use the chain rule. Sine x derivative is cosine x, right? Yes.
Yes.
And you want to make this guy equal 0. And I suppose you know this formula. Who is that guy?
What do you mean? That's the derivative of sine squared x.
Yeah, I know, but who is this guy?
Who is this guy? This guy is an equation.
This guy is a double 2x. correct?
Yes.
Okay. So now you want to make your x on the interval of this guy. And let's look for this guy. 2x go to 0, so that means 2x equals to pi, right?
Yeah.
Or 2 pi. Because x equals to pi over 2. And this guy, x equals to pi. But with this pi, it is out of this range, right?
Yes.
So you cannot choose this one. So you can see this guy is out of my domain. That's it.
Pi over 6 and 5 pi over 6.
Mhm.
Yeah, okay. Yeah, that is
30 degree, 150 degree.
Okay, and if it is in the range, then what? Like, let's say if it was like pi over 6, comma 7 pi over 6.
Yeah, then you choose one more.
Oh, so you'll have two answers for x.
Right. Yeah.
Okay.
The Rolle's theorem guarantee you have one at least.
Okay.
You might have multiple, okay?
Oh.
Yeah, but one at least.
Does MVT also guarantee one?
Right.
Or does MVT guarantee multiple?
One.
Okay.
One is guaranteed. Two is not guaranteed, okay?
Oh, I see.
Yeah.
So the x equals to pi over 2. That is what c is equal to.
That's a c. Yes. That's a c value. So your c equals to pi over 2. Okay.
Okay.
Because
So
the original Rolle's theorem is saying fx is continuous and differentiable on the interval between a and b, right? And fa equals to fb. So there must be a point where x equals to c, so that f prime of c equals to 0. Okay. So you make your f prime x and make it to be 0 and solve it and make sure you choose the one between this. Okay. Or maybe 2. It depends on what interval they give to you. Make sense now? Okay.
All right. I think is that it? I think. Wait. Let me take a quick glance. Because I remember I didn't know how to do most of the questions, and then once my friend asked me to help, all of a sudden I knew how to do it. I was like, "What is going on? How do I know?" All right. Let's see.
And let me repeat this. Okay. So something important for this two theorem is for both MVT and the Rolle's theorem. For both of this, you want to satisfy number one, continuous.
Yeah.
On interval of AB. This is the thing you must satisfy. Number two is differentiable.
Yeah.
Differentiable.
But I don't need to check. Do I need to check for continuous and differentiable for Roy's theorem? Like, could I just plug it in, the 2 points?
Look, if they say find the value, you can forget about this. They didn't ask you to prove. But if they say, please prove, okay, that Rolle's theorem can be applied to this, okay, and then find out the value of C. If they ask you that, then you have to show, well, you see here, you say, oh, well, this is a trigonometry function. You don't have anything in the denominator, yeah? And this is continuous. And then you show f prime x equals 2 sine x and cosine x. This is sine 2x. Of course, this guy is continuous. This value, you have those values. So that shows you are differentiable on this interval, okay? Yeah, you just say it. You see, this is continuous on this. You see, f prime x equals this. So this is differentiable. That's it. Okay. For the Rho theorem, you just do extra step. For MVT, this two is good enough to go. For Rho theorem, you need to say one more, saying, hey, your FA equals to FB. That's why the Rho theorem apply. Okay. So you can treat the Rho theorem as a simple version of MVT, right? Who is MVT? MVT is saying that you have a point at C where f prime C equals to FA minus FB over A minus B. Correct?
Yeah.
For the Rho theorem, because you said you already showed that FA equals to FB, right? So your f prime C equals to FA minus FB. That's 0. So that's 0. Does that make sense? That work, right?
Yes.
Okay. Any other question? If no other question, we will continue
no more.
to the. Let's continue to the. Okay. Let's do the review. Okay. We still have many questions in the review. Right here, they ask you if this guy is which one. Okay. So you choose f x limit x go to 1 plus, right? On the right. So that is 2 times 1 minus 1, which is 1. Limit x go to 1 minus fx. So you are going to choose the left. So that's 1 squared. That's also 1. Okay. So this 2. So I teach you the way you want to prove this one here, up to here, is to prove that your limit at x equals 1 exists. Okay. Yes. If you want to use your phone to record this, I strongly recommend you record this one because
I think it is recording, or you're recording. One of us is already recording.
Oh yeah. Okay. So x go to 1 here because it's 2 equal, right? Yeah. So limit fx x go to 1 plus equals limit x go to 1 minus. If you prove this 2 equal, then your limit at x equal go to 1 exist. Okay.
Okay.
And this equals to 1. Okay.
Yeah.
That makes sense. So showing this guy equals to this guy is to prove that your limit at this point exists. Is this good enough to show it's continuous?
Yeah, right?
No.
What?
Not
Because
yet.
they both equal 1.
No. Listen. This is only show your limit exists. This does not show your function to be continuous. To be continuous, you have to satisfy the next step, okay? Number 2, fx at x equals to 1 exist. Yes? And fx at x equals to 1 equals to how much? There, 1, right? You see? Equals to 1. If I have here, I'm sorry, this one is not continuous because it's not defined. You don't have a position for my x equals to 1. Okay.
Yeah.
So here, that shows this guy exists and this guy equals to 1, right? Number 3. Both your limit at this point exist and your function at this position also exist. So the last step is to say f(x) at x equals to 1 equals to limit x go to 1 of f(x). This equals to this. That guy equals that guy. Then this function f(x) is continuous at x equals to 1. Does this make sense?
It does.
So being continuous is very picky, okay?
Yeah.
Yeah, you have to satisfy this guy and that guy and that guy, okay? So if you have a function like that, that's a jump discontinuity, okay?
Okay.
If you have a function like that, for discontinuity, right? Yes?
No, I'm taking class. I'm not teaching. Yeah, continue.
That makes sense?
Yes.
Yeah, continuous. So, but we want to find out the derivative, all right? The story is not finished. Let's find out f prime x. X go to 1 plus. On the right, who is the derivative on the right? 2, right?
Yeah.
Who is the derivative on the left? 2x. Yes?
Yes.
And then make x go to 1 negative. So this is 2, right? Please don't tell me, teacher, this is negative 2. No. 1 minus, it just means you go to 1 from the left. It is still 1, okay? Don't do a crazy negative 2. That's wrong.
All right.
That makes sense?
So we have to check from limit, like from the positive side and the negative side, and then you have to check from like if it's at 1.
Yeah.
All right.
You do from the left, that's 2x, but you plug in x equals to 1. You do from the right, they give you the answer. And this 2 equal, yes?
Yeah.
So this guy exists, right? So f prime 1 exists. So here, this one is wrong, right?
Yeah.
That's wrong. And that one is wrong. And that one is wrong. So that guy, right? Does this make sense now?
Yes.
I want you to use this example to truly understand and being able to apply continuous and derivable for all your other questions, because this question will also happen in the real AP test. Totally makes sense now?
Yeah.
Next one. Your teacher, by the way, the review here is really good quality, okay? Concave up. So you want to, if you want to get a concave up, what does that mean? You want to have something like that, right? Yes? So you want to do, now you want to do the first derivative and then you do the second derivative, right? Now go ahead, use quotient rule. Oh, you know what? The quotient rule is too slow. Okay, we are smart people. We want to do better way. Okay. Y equals to 1 minus x. So I'm going to change that 1 minus x to be 3 minus x. And then minus 2. Can I?
Yeah.
Does this make sense?
Mm-hmm.
Are they equal?
Yes.
Okay. So if this is equal, look at here. That's -1, right?
Yes.
And then minus 2 times x minus 3, right?
Yeah.
Do you like the quotient way or do you like this way?
I mean, they're both helpful to know.
We can do the derivative easily now, okay? So y prime is equals to this guy is 0.
Yeah.
And then we can do this guy. Yeah. So
yeah.
-2 times x minus 3 to the power of -2, right?
Yeah.
Okay. Because this guy is gone, okay?
Mm-hmm.
Yeah, that guy is gone. And x in front is 1, so you don't worry about any more. This is the first derivative. Let's do the second one.
Yeah.
That is -2 times -2 times x minus 3 to the power of -3, right?
Yeah.
Okay. And you want this guy to be positive, right?
Yeah.
And concave up positive. So what's your answer?
It needs to be positive.
Uh-huh.
Then it'd be what, 3, right?
So this guy will be positive. So x bigger than 3. Does that make sense?
Mm-hmm. So the 1, we don't need to worry about the 1.
Not really.
Okay.
Not really. Yeah, you might feel curious about this question, so we can take a look. So 1 minus x. I strongly recommend that you can do this similar thing as what I show you here, because sometimes if you feel lost about the question, you will be able to go through this and figure out. Okay. You see here? Yeah. And who is in the center? The x equals to 3 is in the center, right?
Mm-hmm.
This guy is an asymptote, vertical asymptote. And this does show you that on the x bigger than 3 on the right, that guy is concave up, right?
Yes.
That makes sense, right?
Mm-hmm.
Yeah, okay. Okay. Now, let's do this one. This is a pre-cal question. Yes. This one doesn't qualify for a calculus question. Who is the asymptote? You can tell me.
Asymptote 2?
Yes. No, I don't accept this kind of answer. You give me a equation.
It doesn't need, okay, let's see.
You have
so
two.
if it's 0 if it equals to undefined from the bottom, would that be horizontal?
No, make this guy equal 0. That's vertical asymptote.
Okay. So then that would be -2, 2. So there's 2 verticals.
Who are they?
2 and -2.
You give me equation. Don't give me just a value.
Equation?
Yes.
4
that is
minus
the vertical.
x squared, right?
Yes.
Oh, you want me to say x equals 2?
Yes, please.
Okay.
Because mathematically, this is different meaning, right?
Yeah.
Okay. X equals 2 is a vertical line. X equals -2, that's a vertical line, right?
Yes.
2 means what? No, in 2D, you don't know 2 means what, okay?
Mm-hmm.
Go ahead.
And then let's see. Equals 0. It'd be 1 horizontal.
Mm-hmm.
So x equals, no, y equals 0.
Really?
Yeah.
Go
Like,
ahead and draw this one. Look at this. Don't answer too quickly. We did this in pre-cal and also algebra 2 pre-P.
Because you set that to 0, right?
But
you make y 0.
You want to see this guy's highest order. You want to see this guy's highest order. Why you forget?
So that. Oh, I was doing solve for x. Okay. So they're the same. So then it'll be -2.
Yes. Thank you. Does this make sense now?
Yeah.
Mm-hmm. So which one you choose? E, right?
E, yeah.
Okay. 21. You go ahead, try this one. This is those kind of holes, okay? That's a hole, and you want to figure out what you want to make your F1 equals, okay?
Okay.
Give it a try. Use the knowledge that we learned in algebra 2. Do you want me to give you more hints?
Wait, let me think about it. So it says in order for the function to be continuous at x equals to 1, the value of f of 1 must be what? Infinity?
You see?
I need a hint.
You see, this guy can be simplified by this, right? Yes?
Yes.
So your original fx, if they say this guy equals this guy, then because your denominator couldn't be 0, so this guy is not continuous.
Yeah.
At x equals to 1, right?
Mm-hmm.
Okay. But if you simplified and you found out that guy at 1, this guy equals to 1, right?
Yeah.
So you can say, all right, I'm going to make my fx equals to this.
Okay.
I'm going to make my fx equals to this fraction. I know that this guy doesn't exist at x equals to 1, but I'm going to fill the hole, because if I make this guy equals to 1, that guy is going to make my hole filled, correct?
Yeah.
That's why this one. Correct?
Mm-hmm.
This get canceled, your value make it to be 1, right?
Mm-hmm.
Correct?
So normally 1 can't be the answer for x, right?
Right.
Because of the
hole. So what you do, and that's what we did in algebra 2. we simplify this, make it this guy equals to something. Yeah, if here is 2x, here is 2x, then my f1 equals 2 times 1. Just this guy because it's just x, so that's just x. X equals 1, so that equals to 1. Does that make sense to you?
Yes.
Okay. Well, these few practice are very good examples. Okay. Now give a try for this one. I want to see if you truly understand the previous question. You can do this one. How do you do this?
C equals 2. Okay.
You might have to do something tricky, okay?
Okay.
A teacher give you this type of question, which belong to the hardest question about this being continuous, okay, for those AP tests. That's a very good question.
Why would you move square root to the bottom? Because don't you not want square roots on the bottom?
Nope, because I'm doing the conjugate. During the time we learn about the limits, like the first 2 weeks of the calculus class, when we calculate those limits like that, we want to times those conjugate so that we can find out, because x equals to 5, this guy does not exist. But if I want to find the limit, I want to cancel the x minus 5 as my factor so that I'm able to find out my limit value. Do you remember?
Okay.
That's been a long time ago, right?
Oh, so you move it down below so you can cancel it out.
Right. When you cancel it out, x minus 5 doesn't matter.
Yeah, once you cancel out, then you can you plug in 5.
Right. Same thing as here.
Solve for. Okay.
When your x minus 1 cancel out, then you will be able to plug in, correct?
Yes.
If you don't cancel out when you plug in, your denominator is 0, which doesn't exist. To get the limit at x equals to 1, you have to cancel out the x minus 1. To get the limit at x equals to 5, you have to cancel the x minus 5. Okay? This is a very good question, okay?
I'm in class, Katie.
Is that your iPhone?
Yeah.
That makes sense?
Oh, I thought that.
Yeah.
24. Oh, we already did so many practice. You can try
Go.
22. Which one you choose?
Well, you can cancel it out, and you
Yes.
have x plus 6.
Yes.
So let's see. So it's continuous at 6. That's not right. It's not continuous at 6.
Why?
Because in the original equation it says oh wait, no, it says if x equals 6, then it's 12. Okay. So it's continuous at 6. And f of x, f is defined at, what does it mean by f is defined?
You see? Define it. This guy is called define.
Oh, okay,
You have values.
that's true
They
too.
give you the value.
Okay, so f is continuous, that's right. And f is defined at 6, that's true too.
So?
Is it all of them?
Yes.
Oh, yeah.
Good job. You made it.
Yeah, and I made it home.
Oh, this is what we did just now. Okay.
Oh, yeah. Why they gotta do decimals? Like, that's not right. Okay.
Yeah, you want to find out. Yeah.
And find number C, satisfying mean value theorem. So sine of 1 is what? Sine of 1.
You have to do in calculator. Okay. You are looking for cosine x sine 1.5 minus sine 1 divided by 1.5 minus 1. So would you please use your TI Inspire and make sure you change it to the reading, because if you don't, if it's in degree, your calculation will be wrong.
Oh, yeah, I never remember that.
Okay, so you must change this to reading first. And you double check. If you type in sine 30, if they give you a 0.5, it is wrong. It is still in degree. Okay.
Did something happen?
Go ahead, use your calculator. Okay.
So sine of x. Wait, no, not sine of x. Wouldn't it be negative cosine x needs to equal to 0.312048?
Hold on. Did you type in this? How much this equal?
Yeah. Mm-hmm. Yeah, that's what I got.
And then you do cosine inverse. Okay.
Cosine inverse, is it not negative cosine?
Negative. Really? Who teach you that? Cosine inverse
Oh,
is
no, that's the other way. That's when cosine turns into negative sine, right?
cosine inverse. Okay. Use the trig button. Okay.
Yeah.
There is
No,
the
I'm
cosine
saying
inverse.
I just got it. I got it wrong when I did the derivative of sine. I flipped it. I got 1.253.
That makes sense?
Yeah.
Okay. Totally makes sense, right?
Mm-hmm.
Now 26. If I prime x exists on this interval, then it follows that, well, if your derivative exists, constant? No. You don't have to be a constant to be able to be differentiable, okay?
Mm-hmm.
So A is wrong. There must exist number so that f prime c, no. You didn't see f a equals to f b, right?
Mm-hmm.
Okay, so there's no such kind of conclusion. C, the function has a maximum on the open interval. B, the function has a minimum.
Can we
You
just?
cannot.
It's the last
It is
one. B.
Yeah, it is the last one.
Because you don't have enough information for those, right?
Right. The problem here is sometimes you have those minimum maximum at your edge. This one, if they change this one to the close, then it's okay. But it's open, it's wrong. Okay.
Okay.
Okay. All right. I'm going to upload your notes to your Google Drive. Okay.
Mm-hmm.
This one will covers everything. When is your exam date?
I'm not sure, but definitely not Monday. I don't think. I really hope it's not Monday.
Okay. Be on
I
time
hope
next
it's
class.
after.
Yeah, sure. Be on time next class so that we can cover all this
Yeah.
in next class. Okay.
Mm-hmm.
Yeah, I have a class right after this, so I'm not able to give you extra time.
Yeah, it's okay.
Okay. Yeah. See you next week.
Yeah.
Okay.
See ya.
Bye.
Bye.